I can check energy balance by taking my boundary condition and dragging in to solution, and it adds a reaction probe. So that gives me the amount of heat that is, or the heat rate through the convection boundaries. And you can understand this by analogy to structural mechanics, where if I applied a displacement boundary condition, the reaction would be the amount of force needed to hold a particular surface, for making the displacement zero, for instance. And then if I say evaluate all results, and then if I expand results over here, it tells me, the amount of the rate of heat loss through the surfaces where, we've applied convection is 15 watts. And I can check that, that should balance the amount of heat being generated, which is this value times the volume of that region of the LED. And the volume of the LED you can get by going in here in geometry, LED, and highlight properties, and you should get the volume here. Okay, so by multiplying that volume with the internal heat generation, that's the amount of heat that's being put into the system, and then this is the amount of heat, or the rate of heat, that is being lost, and you can check energy balance that way. I want to refine the mesh, and there are a couple of ways to do this. One is to go in and play with the mesh settings and get a more refined mesh as shown over here. I am instead going to use the adaptive mesh refinement capability and get the solver to refine the mesh where the temperature gradients are high. So I will go to I'll go to my ANSYS project, disable section plane, and maybe look at the details tab. And what I'll do is I will go to temperature. By the way, if you notice, the maximum temperature is around 44 Celsius, and the total heat flux, the maximum, is around 64,000 watts per meter squared. Let's see how those change as I refine the mesh. So what I'll do is I will highlight temperature in the tree, right click, say insert convergence. And so it'll refine the mesh until the maximum of the temperature won't change by 20%. Let's say we want it to not change by 5%, by more than 5%. And I can, once I have the convergence object, I can go back into solution, and it'll show me, like how many refinement loops, if I wanted to do multiple refinement loops and so on. We'll just ask it to refine it once here in the interest of time. And so it shows me the maximum temperature at the start, the initial number of nodes, and I will click on solve. After a few moments, you will see that it reports the results, and the number of nodes increased from around 17,800 to around 47,000. Okay, and so that means that's the corresponding increase in the number of temperature values that need to be determined directly, or that gives you a sense of the size of the number of algebraic equations that need to be inverted simultaneously. And you can see that the maximum temperature didn't change very much. And if you go over here, you can see the refined mesh by going under edges, show elements. Under mesh, I can see the original mesh, and then when I look at the results and turn on elements, I can see the refined mesh. And so you can see that it refined the mesh over here in this region near the LED where the temperature gradients are the highest. But that didn't make a big difference to the maximum temperature. The maximum heat flux changed much more. So the maximum heat flux the heat flux tends to be much more sensitive than the temperature, because ANSYS calculates it by taking the gradient of the temperature, and anytime you take a gradient, your numerical errors will increase. So I think our original mesh is good enough for our purposes here, and just to keep the file size small, I will just delete the convergence object, and I will save the project.